My sincere apologies for the sound problem. If we are calculating the sides or the angles of this triangle, what you will notice is that we cannot use SOHCAHTOA. We cannot use Pythagoras theorem. And the reason for this is that we are only working with right angle triangles. So now what we need to do is we need to find a way of saying, okay, how can we actually work on calculating the angles or the sides of this particular triangle? Now, this is what we need to do. So if you can remember from grade 10, we said that sides are always named according to the angle which is opposite them. In other words, what we are saying is if this is uppercase A, this is going to be lowercase a. If this is B, uppercase, then the side opposite to it will be B, lowercase. If this is uppercase C or capital C, the side opposite to it will be lowercase c. If you remember this from geometry grade 10, we said when we are naming sides of a triangle, we always need to make sure that we name them according to the angles which are opposite to them. I hope that that makes sense. So, having said that, let's see what we can do here. In order for us to be able to use anything, we first need to construct a perpendicular height. So from C, I'm going to construct a line which is going down to the base of the triangle, down to AB. This is a perpendicular height. Whoops, let me fix that. This is going to be our perpendicular height. I am going to call this H, and the point where it meets the x-axis, let me call this point D. Now, just remember that the C that we have here applies to the entire AB, not to just one portion of it. Right. When we look at this diagram, we actually have two triangles. To be specific, we've got two right angle triangles. We could use these two right angle triangles in order for us to be able to calculate something useful, in order for us to be able to generate something useful. For that, this is what we can do. So the first thing I will do is I will see that I only have, that's a very thick pen. What I could do is I can highlight the right angle triangle in my first, I've got a first triangle here. This is a right angle triangle. Now notice, I am going to say here on this side that in triangle ACD, if we look at this, when we use A as our reference angle, we can actually calculate the length of AD. Now, the length of AD is going to be the x-coordinate of C. So let's do that. We have got B, which is our hypotenuse, and we've got H, which is our opposite. We could use the trig ratio of sine. So sine of A is going to be equals to, the opposite is H over the hypotenuse is B. Whoops, I made a little bit of a mistake here. We are supposed to use cos because we're looking for AD. So cos of A is equals to the adjacent is AD over the hypotenuse, which is B. Now, to solve for AD here, I need to multiply both sides by B. This is going to cancel this. I'm going to have AD is equals to B cos of A. So my x-coordinate of C is going to be B cos of A. Now, in the very same triangle, when I'm calculating the y-coordinate of C, I need to use the length of CD, i.e. I need to calculate what H is. Now, H is opposite A. This is where we could use our sine trig ratio. So sine of A is equals to the opposite is H over the hypotenuse, which is B. Once again, we are solving for H, so multiply by B, multiply by B. This is going to cancel this. I'm going to have H is equals to B sine of A, like that. So this is going to be B sine of A. Our diagram is complete. Now you might be wondering, why are we using this diagram? Well, first, let me shift some of my writing over to the side. We are going to use this diagram to actually prove the sine, cosine, and area rules. Okay, nevertheless, let's copy this diagram over to the next page so that we can start looking at the proofs. So let me paste that right here. There we are. There's a couple of things I don't need here, like that. I still have my B here. Now, the first thing we're going to prove is what we call the sine rule. First, I'm going to work on the proof of the sine rule. Then I will explain why we need to use, why do we have the sine rule, and why exactly we need to make use of the sine rule. What purpose does it serve? So, here we are. The first thing we need to notice is that we've got not only triangle ACD as a right angle triangle, but if you notice, we also have triangle CDB as a right angle triangle, like that. In this triangle, we can also solve for H, but this time we could use B as our reference angle. So I could say in triangle CBD, B is my reference angle, H is opposite B, A is my hypotenuse. So I can say, once again, sine of B. This is equals to the opposite, which is H, over the hypotenuse, which is A. I'm going to multiply by A here, multiply by A there. This will cancel this. H is equals to A sine of B. Now we've got two expressions for H. We've got H being B sine A, we've got H being A sine B. How about I equate this? And so before I equate this, let me just write down what the sine rule is. So you've got A over sine A equals to B over sine B, which is equals to C over sine C. There we are. What I can do is I could say, okay, now that I've got H here and I've got H there, let me equate the two. So B sine of A is equals to A sine of B. What we can do from here is we can divide both sides by sine A sine B. I'm going to divide this side by sine A sine B. What's going to happen is sine B will cancel sine B, sine A will cancel sine A. What we will remain with is the following. We've got B over sine B is equals to A over sine A. And this is actually the sine rule. Now take note of something. In your exam, you only need to prove up to this part. Now you might be asking yourself, why do we then have C over sine C? For the purposes of your exam, if they ask you to prove the sine rule, it is enough for you just to get to this point. You do not need to prove all three ratios. As long as you have proven that two of them are equal, you are good to go. Now, we can also write our sine rule formula as sine A over A is equals to sine B over B, which is equals to sine of C over C. Honestly, it does not matter which one you use. Some textbooks will say to you that you need to use the second one if it happens that you are trying to find an angle, and you need to use the first one if you're trying to find a side. But on a serious note, it does not really matter which one you use. When do we use the sine rule? So, the sine rule is used when you have two angles and one side. The sine rule is also used when you have two sides and one angle. Now, using the sine rule, we can calculate sides or angles of a triangle which is not a right angle triangle. Remember earlier we said using Pythagoras theorem and using the trig ratios, you can only calculate sides and angles of a right angle triangle. With this approach, you can actually calculate the sides and angles of a triangle which is not a right angle triangle. let's actually look at an example of when we would do such. So here's a diagram where they ask you to calculate for the value of x. Now, the first thing we need to do, or the first thing I recommend that you do, is to write out your formula. For this specific triangle, I have got sine j over j is equals to sine k over k, which is equals to sine L over L. Now we need to check. We are calculating x, which is angle L. So the formula that we need to use must contain L. We have got angle K, we have got side K, so we need K in our formula as well. In other words, I'm going to eliminate this part. Then the formula I'm supposed to use will be sine K over K. This is equals to sine of L over L. Now we can substitute what we know. This is going to be sine of, the value of K is 75 degrees, over side K, which is 13. This is equals to the sine of X over, let's see, side L, that is 8. I am actually running out of space, so let me just move some of my questions down a little bit. Let's move these diagrams down. Now, I know when you're looking at some of these questions, you might think to yourself, my goodness, how do I ever get to solve this? Don't worry, we'll actually work through each of the questions that we have prepared here. So, this is what we need to do. We have got, from this step, we can cross multiply. We are going to have 8 sine of 75 degrees is equals to 13 sine of x. I'm going to divide by 13 and I'm going to divide by 13. This will cancel this. Now I'm going to have sine of x is equals to 8 sine of 75 degrees over 13. My advice is do not type this into the calculator as yet and then write down your answer here, because you're going to get into trouble with rounding off. Instead, what you can do is write it as is, and then now you're going to say x is equals to, we're trying to solve for x, so we need to take the arcsine of 8 sine of 75 degrees over 13. When you type this into your calculator, you actually get the value of x, which is an angle in degrees. Awesome. I hope that this makes sense to you guys, and I hope that you understand exactly how we go about doing this. Brilliant. You can type this into your calculator and then get your final answer. But for now, let's move on to the next question. The next question says we need to calculate PQ. Now, if you look at this, we said that we could use the sine rule when we have two angles on one side, or if we have two sides and one angle. When you look at the diagram, the first diagram we worked on, we had two sides and one angle. That's why we could use the sine rule. Now, technically speaking, when we look at the second diagram, you might think we've got two sides and one angle. Let's use the sine rule to get PQ. Excuse me, actually we already have PQ here. The question meant to say we need to calculate the value of PS. Now, when you want to calculate the value of PS, you can actually not use the sine rule here. Why? Because 143 is between two known sides. This type of an angle is what we call an included angle. The sine rule does not work with the included angles. The cosine rule is what we use for included angles, but since we have not yet touched the cosine rule, we will come back to this question a little later on. Let's move to the next question. So, we have got a scenario here where we've got two triangles in one diagram. And the question says to us, we need to express MT in terms of theta. Now, the first question that you need to ask yourself is, where is MT? Well, MT is a common side between two triangles. You need to check which triangle has the most information. Which triangle has this theta? And the triangle that we are supposed to use that has theta is triangle STM. Now, when you are writing, you need to indicate that whatever you are going to be doing here is in triangle STM. That way the marker knows when you're referring to an angle, which angle exactly are you referring to. Brilliant. When we look at triangle STM, we are given two angles and one side. We can actually use the sine rule. Now take note of something. It does not matter that we do not know what the value of theta is. The question says we need to express our answer in terms of theta, meaning that our answer is supposed to contain theta. What the value of theta exactly is, we're not interested in right now. What we are interested in is just finding an expression for what the value of mt is. Now, once again, on the side, I am going to write my formula for the sine rule. So I'm going to have m over sine m is equals to s over sine of s, which is equals to t over sine of t. Now, when you look at this, we once again need to identify which angles and which sides do we have. Okay, we have angle s, and then side s, which is this mt, we don't have. We need to include this because mt is what we're solving for. Now, this is going to be lowercase t, this is lowercase m. We've got angle t, and we've got side t. So we need to use this part. The m's are not relevant. So we can discard this part and then just work with the two ratios that we have. So for s, this is, let me just write this down first. So s over sine of s is equals to t over sine of t. Now, for s, we have got mt, that's what we're solving for, divided by sine of s. This is sine of theta. This will be equals to t, which is 4 over sine of t, which is sine of 30. Once again, when we get to this point, we need to cross multiply. Let me just make some more space down here. So let's move this down. When we get to this point, this is where we need to cross multiply. After cross multiplying, we get mt is equals to, sorry, this is mt sine of 30. And this is equals to 4 sine of theta. We're solving for mt, so divide by sine of 30 degrees and divide this by sine of 30 degrees. This and this will cancel. Your mt is equals to sine of 30 is 1 over 2. 4 divided by 1 over 2, that's going to give us 8 sine of theta. There we are. We have answered our question. The question said we need to express in terms of theta. Because we are expressing in terms of theta, our answer must contain theta. Our answer does actually contain theta, so we are good to go. Brilliant. I hope that this makes sense to you guys. Let us look at the next section. It says, hence, express k in terms of theta and alpha. K. In which triangle is k? Well, if you look at this, k is in triangle MTP, this triangle. Take note that this is a right angle triangle. So first what I'm going to do is I'm going to say here on the side in triangle MTP. We are solving for k, and we have MT, which is our hypotenuse. K is opposite alpha. We're using alpha as our reference angle. Opposite and hypotenuse, that's sine. So we will say sine of alpha is equals to the opposite, which is MP, over the hypotenuse, which is MT. So sine of alpha is equals to, for MP, this is going to be K over MT. We calculated that earlier and we got 8 sine of theta. The question wants us to calculate K. So I'm going to multiply by 8 sine of theta both sides. Multiply by 8 sine of theta. Now, this is going to cancel this. You've got K is equals to 8 sine of theta, sine of alpha. And we are good to go. Now, please take note of something. I'm not sure if your teachers actually mentioned this to you, but when you are answering a question in mathematics, whenever the question says hence, it always means you need to use the answer to the previous question in order to answer this question. I hope that this makes sense to you guys. And if I'm moving too fast, don't worry, I am going to send everything here to those people who subscribed. Thank you once again for those of you subscribed, and for those of you who actually signed up for the session. I am going to forward these notes to you after the session so that you have access to whatever we were doing here if ever you need to revise. Now, I'm going to copy the diagram that I was using earlier. And then I'm going to go over to the section of the cosine rule. Once again, this diagram is extremely important. If you understand how this diagram is constructed, then in your exam, whenever you're asked to prove the cosine rule or the sine rule, then you know exactly what to do. Okay, let's look at what's happening here. We want to prove the cosine rule. Let me just make some more space here. To prove the cosine rule, what we need to do is, we actually need to check the side BC. And we need to calculate the length of BC. Now, if you can remember, the length of BC, since we've got the coordinates of BC, we can actually make use of the analytical geometry distance formula. So BC squared is equals to x of c minus x of b all squared plus y of c minus y of b all squared. So BC, that's a squared. This is equals to the x value of c. By the way, we forgot to get the coordinates of b here. Now, the distance from a to b is the x coordinate of b, because a to b, they are measured from the origin. So the x coordinate of b would be c, and the y coordinate is 0 because it's on the x-axis. Let's substitute. X value of c, this is b minus, this is b cos of a. B cos a minus the x value of b, which is c all squared, plus the y value of c, that is b sine of a, minus the y value of b, that's just going to be 0 squared. So a squared would be equals to, this is b cos of a minus c into b cos of a minus c. Then for the second bracket, this is just going to be b squared sine squared a. If you multiply the brackets out, you will get something like b squared cos squared a minus 2bc cos of a plus c squared. This is going to be b squared sine squared a. Let's just write down what the cosine rule is. So a squared is equals to b squared plus c squared minus 2bc cos of a. We are proving this formula. Let's have a look at what's happening here. If you look carefully, you will notice that we have a common factor. I can group b squared cos squared a and b squared sine squared a. So a squared is going to be equals to, this is b squared cos squared a plus b squared sine squared a plus c squared minus 2bc cos of a. Now, when we take out our common factor, let me continue on the next line. A squared is equals to, we have a common factor of b squared. So we take out b squared as a common factor and we remain with cos squared a plus sine squared a. Then this is plus c squared minus 2bc cos of a. A squared is going to be b squared, if you remember from your trig identities. This is going to be 1 plus c squared minus 2bc cos of a. So a squared will be equals to b squared plus c squared minus 2bc cos of a. There we are, we have proven the cosine rule. Now, just like the sine rule, the cosine rule has multiple ways that we could write it. We could use this formula, Or we could say b squared is equals to a squared plus c squared minus 2ac cos of b. We can also have c squared be equals to a squared plus b squared minus 2ab cos of c. Now, when do we use the cosine rule? We use the cosine rule if there's two sides and an included angle. Remember, we spoke about the included angle earlier. We said the included angle is the angle which is between two known sides, the angle which is between two given sides. We also use the cosine rule when we have three sides. Brilliant. I hope that this makes sense to you guys and that you're understanding what's happening so far. Let's actually go ahead and look at some questions. So here's the first question that says we need to calculate theta. Once again, I'm going to move this stuff down. There's a lot of clutter on the page. Okay, there we are, we're calculating theta. Once again, let's label this to be Q. Let's label this to be S. Let's label this to be J. Now, you need to be very careful as to which formula you actually use and how you arrange your letters. Because J is the unknown angle, our formula must begin with J squared. This is going to be equals to Q squared plus S squared minus 2QS cos of J, like that. Now, the value of J, this is 18.5 squared. This is equals to Q, which is 17 squared, plus S, that's 15 squared, minus 2 times 17 times 15 cos of theta. Now we need to rearrange this so that we've got cos of theta on one side. I am going to transpose these two. So this is going to be 18.5 squared minus 17 squared minus 15 squared is equals to negative 2 times 17 times 15 cos of theta. Now from here, what you can do is you can divide both sides by negative 2 times 17 times 15. Then divide this side by negative 2 times 17 times 15. This is going to cancel that. So we are going to remain with cos of theta is equals to 18.5 squared minus 17 squared minus 15 squared. Then all of this is divided by negative 2 times 17 times 15. Once again, do not type this into your calculator. Instead, what you do is you say theta is equals to arc cos of 18.5 squared minus 17 squared minus 15 squared. Then all of this is divided by negative 2 times 17 times 15. You type this into your calculator, you get the value of theta, which is going to be in degrees. Life is great. Let's look at the next question. The next question says calculate zy in terms of theta, p, and k. Now you see here, this is very similar to what we did in the previous section on the sine rule. What we need to make sure of is that because the question didn't tell us step by step like in the first case where to start, we need to identify the triangle with the most information. In this case, when I look at triangle WXY, I will see the triangle WXY has two sides and an included angle. I can actually use the cosine rule to solve for xy. So this is going to be x, this is going to be y, this is w. So cosine rule, w squared is equals to x squared plus y squared minus 2xy cos of w. So this is going to be equals to k squared plus, this is p squared minus 2kp cos of theta. This is going to give me k squared plus p squared minus 2, this is squared, kp cos of theta. This is w squared, by the way, so we need to find the square root here. There we get that w is equals to the square root, whoops, that's a terrible square root, the square root of k squared plus p squared minus, this is p squared, minus 2kp cos of theta. There we have it, life is great. Now that we have w, we can actually go over to triangle XYZ. So in triangle XYZ, the question said we need to calculate ZY. Since we have w, let me just highlight the triangle that we have. So this is WXY, sorry, XYZ. If you can remember, this is a right angle triangle. Seeing that it is a right angle triangle, this means that for us to calculate YZ, we need to use the trig ratios. Now, W, I already know it's opposite my reference angle of 30 degrees. ZY is my hypotenuse. Opposite and hypotenuse, that's sine. So sine of Z is equals to, the opposite is W over hypotenuse is just ZY. So sine of 30 degrees is equals to, we got the value of W as the square root of k squared plus p squared minus 2kp cos of theta. And then we are looking for zy, which we do not know. So zy is going to be equals to the square root of k squared plus p squared minus 2kp cos of theta. And then we are going to divide all of this by sine of theta. Whoops, that's a skewed line. This is all going to be divided by sine of theta. Now sine of theta is a special angle, that's 1 over 2. So actually what's going to happen is this is going to be 2 square root of k squared plus p squared minus 2kp cos of theta. There we have it. We have calculated the value of zy. Brilliant. Life is great. I hope that this makes sense to you guys, that you're understanding the content and that you're still following along. Let's move on to the next section. We still have a question here. And this question wants us to calculate QR. Now, we do not have two sides and an included angle. We've got two sides, yes, but we do not have an included angle. As a result, what we need to do here is we need to say, okay, we could use the sine rule, because remember the sine rule we use if we've got two sides and one angle. So let's label our sides. This is P, this is Q, and this is R. So I'm going to say sine of P over P is equals to sine of Q over Q, which is equals to sine of R over R. Let's see what we need and what we don't need. R is needed because we've got the 13 and we've got the 56 degrees, so we're going to keep this. Q is needed because we've got the 15 and we don't have angle Q. Now you might be asking yourself, but aren't we supposed to keep P because P is what we're looking for? That's absolutely correct. However, we do not know angle P, we do not know side P. So for the time being, let's just discard this. And here's what we're going to do. We're going to have sine of Q over Q is equals to sine of R over R, like that. Let's substitute what we know. This is just going to be sine of Q over 15. That's equals to sine of 56 degrees over 13. We are solving for Q, so let's cross multiply. We're going to have 15 sine of 56 degrees is equals to 13 sine of q. Whoops, this is sine of q. Divided by 13, divided by 13. This is going to cancel that. Once again, do not type this into your calculator as yet. What we need to do is we need to say sine of q is equals to 15 sine of 56 degrees divided by 13. Then I'm going to say q, not theta, q is equals to arcsine of 15 sine of 56 degrees over 13. Now, I'm actually going to type this into the calculator because I'm actually interested in what the answer is, because we still need to use this answer in the next step of the calculation where we need to calculate what the value of QR is. So when I type this into my calculator, I get a math error. Now you ask yourself, how is this possible? Well, our Q is undefined. Now, if you get an angle or a side which is undefined, it simply means that the type of triangle does not exist. Yes, it is possible that you get tricked, where you're given a triangle that has a value of theta or an angle that you're supposed to calculate, but for some reason you get undefined. Remember, theoretically speaking, these are just numbers. We're supposed to be able to calculate anything anyhow. But there are cases in which what you're calculating does not make sense to have. And because we do not have a value for angle Q, we cannot calculate what QR is, and therefore the question would be undefined. Wonderful. Life is great. I hope that this makes sense to you guys and that you're understanding so far. Let's move on to the next section, which is on the area rule. And once again, I need to bring back my diagram here. Now, the proof of the area rule is not assessed in your exam, but I'm just going to do it so that you can see how we go about finding these formulas. So, according to the area rule, the area of a triangle is given by 1 over 2ab sine of c. This can also be written as 1 over 2ac sine of b. This can also be written as 1 over 2bc sine of a. Let's prove this. Remember, we said earlier that our area of any triangle is half base times perpendicular height. Now, the base that we have in this particular triangle is the C, side AB. So this is going to be 1 over 2 times C times the perpendicular height is H. We established H to be B sine of A. And hence, if you simplify this, you get 1 over 2 BC sine of A, which is actually what your area rule is. Now the question might be, where do we use the area rule? First of all, we use the area rule if we are asked to calculate the area of a triangle, which is not a right angle triangle. You also use the area rule if you are given two sides and an included angle. There we are. I hope that this makes sense to you guys. So the area is calculated under the same conditions as the cosine rule. You must have two sides and an included angle. Let's have a look at some questions on calculating the area. So the first question here says we need to calculate the area of triangle AKP. Let's label our sides. This is K, this is P, and this is A. Now, we do not have two sides and an included angle. So we need to make sure that we first calculate what our included angle is. Once we have the included angle, only then can we calculate the area of this triangle. Now, we can calculate the angle of we can calculate any included angle here. Let's say I'm interested in calculating P. Then I need to use the area rule, the cosine rule, because remember we said earlier that we use the cosine rule where we have three sides as well. So P squared will be equals to A squared plus K squared minus 2AK cos of P. In fact, let me rearrange my formula. P squared minus A squared minus K squared is equals to minus 2AK cos of P. When I divide by minus 2ak both sides, this is going to cancel that. I remain with cos of p. Cos of p is going to be equals to p squared minus a squared minus k squared divided by minus 2ak. So let's substitute this. The value of side p, this is 14 squared, minus the value of side a, that's 16 squared, minus the value of k. The value of k, let's see, what do we have there? That's 18 squared. Divided by minus 2 into the value of a is 16, and the value of k is 18. So, to get the value of p, I will say this is arc cos of the 14 squared minus the 16 squared minus 18 squared divided by minus 2 times 16 times 18. I'm going to type this into the calculator so that we actually get a proper answer before we move on to completing the question. So it is important for you to understand exactly when to use which rule. If not, then you will have some problems with these trigonometry questions. They're honestly not difficult. Yours is just to be able to figure out where exactly you need to apply a specific rule, which triangle has the most information, excuse me, and then work with it from there. I get my angle P is 48, 19 degrees. So this is, let me use a different color. This is 48, 19 degrees. What I can then do from here now is I've got an included angle. Let me calculate the area. So the area is going to be 1 over 2 of your two sides sine of included angle. Please take note of this. So this is 1 over 2 times 16 times 18 sine of 48, 19. And if I type this into my calculator, I should get the area of this triangle. So just remember that the way you write the formula is quite important, because the angle that you are using must be your included angle. My answer here is 107,33 square units. Remember, this is area, so we need to put square units. This means that if we put in, if this was centimeters, let's say it was centimeters here, centimeters there, your answer would be centimeters squared. But since we do not have any meters, centimeters, kilometers, we just put square units so that we know its area. Okay, now we look at our last question for the specific session. In this question, we are asked to calculate the area of a quadrilateral PQRS. Now, we need to consider the fact that there are two triangles here. And I basically need to calculate the area of the two triangles. Now let's think about this first. For me to calculate the area of triangle PSR, I can use the area rule because I've got two sides and an included angle. But when I look at PQR, it's a right angle triangle, so I'm supposed to use here half base times perpendicular height. I do not have the height of QR here, so I also need to calculate that. This is telling me before I calculate the area of PSR, I need to calculate PR first. So let's name this S, let's name this P, and let's name this R. So, according to my cosine rule, because I've got two sides and an included angle, S squared is equals to P squared plus R squared minus 2PR cos of S. I'm just going to put this as for P. This is 26 squared plus R. This is 12 squared minus 2 times 26 times 12 cos of 60. And I'm going to put this underneath the square root sign to get the value of PR. Let's do that and get our answer. And by so doing, what we are looking at is we're trying to find a side which is common between the two triangles. And then from there, we would use Pythagoras theorem to calculate the base of our right angle triangle, which is QR. I hope that you guys understand how we came about that specific choice. So my answer here, I'm just going to write it in simple surd form. It's 2 square root of 127. So this is 2 square root of 127. Now what I can do is I can go to triangle PQR and I can actually calculate the base because I have the perpendicular height. So, whoops, there is triangle PQR. Now what I need to do is to calculate the base. I'm given the hypotenuse right there. I'm given 21. I'm not going to use trig ratios because I do not have any angle. Instead, I'm going to use Pythagoras theorem. So QR squared is equals to my hypotenuse squared minus PQ squared. This is going to be 2 square root of 127 squared minus PQ, which is 21 squared. And let's see if I type this into the calculator what it's going to give me. So 2 square root of 127 all squared, whoops, minus the 21 squared. And I get this to be 67. This is QR squared. So in other words, to get the value of QR, this would just be the square root of 67. This is not what the question asked me. I am not done. What I now need to do is to calculate the area of the entire thing of PQRS. This is going to be the area of triangle PQR plus the area of triangle PRS. So let's see. For the area of triangle PQR, this is half base is PQ times perpendicular height, which is QR, plus. For the area of triangle PRS, I'm going to use the area rule. So this is 1 over 2 times PS, my two sides, times the sine of my included angle. Let's substitute this. For PQ, this is 21. For QR, that's the square root of 67 plus 1 over 2 times PS. Do we have PS? Yes, we do. PS is 12 times SR. Do we have SR? Yes, we have. That's 26 times the sine of 60. All you now have to do is to type this entire thing into your calculator so that you can get the final answer. So let's just type this into the calculator, get the final answer. This is 67 plus 1 over 2 times 12 times 26 sine of 60. And we get an answer of 221,05 square units. Brilliant. And that marks the end of our session of the sine, cosine, and area rule for grade 11 trigonometry. I hope you guys found this productive. I hope that you enjoyed it, and I hope that you've learned a thing or two. Once again, we do apologize for the technical issues that we had earlier on. We had an issue of sound at the beginning of the broadcast. But to those of you who actually signed up via live.brainshift.co.za, we are actually going to forward this to you after this lesson via email. I hope you guys found this lesson productive. I hope that you enjoyed. I hope that you actually learned something. If for some reason you detect that we have any errors in the questions, if you see any difficulties, or if you have any questions, please do send us an email at live@brainshift.co.za. So that's live, L-I-V-E, at brainshift.co.za. Please point out the error and we shall be happy to assist you. Thank you guys so much for joining us. Thank you for taking time to be partakers of the session. Thank you to those of you who actually spread the word that this session would be possible and that people would actually be able to watch the session. Until we meet again, please take note that next week there's another session for grade 10 It's going to be grade 10 functions and graphs. So if you're interested, you can sign up again at live.brainshift.co.za. Join us for the session. And yeah, thank you guys for watching. Enjoy the rest of your day. Bye bye.